Okay. Hello to all those who are watching this. We're going to be working on using graphs and tables to solve linear systems. So that is our lesson objective today, is we want to solve systems of linear equations, but I'm just going to put here systems. Solve systems using graphs and tables. Now, there is some vocabulary terms here. I'm not going to fill them in. I will read through them what they are. Systems of equations. What is a system of equations? Is a set of two or more equations containing two or more variables. A linear system is a system of equations containing only linear equations. A consistent system is a set of equations or inequalities that has at least one solution. An inconsistent system is a system that will have no solutions. An independent system will have one solution. A dependent system has, let's say, multiple solutions. Okay, we'll discuss those a little bit more as far as classifying. What I would like, though, is for those of you listening to this, put the vocabulary terms, get those definitions. They tell you what page numbers on the textbook. Add them in there. Show them to me on Tuesday. And let's add extra points to your next quiz or test. Okay, so at this point we're ready to say what is a solution. Okay, we're looking at linear equations, so all the graphing y equals mx plus b, we're going to come back to that. Now every point on a line is considered a solution. For it to be a solution on a system, we're looking at two lines. It is a solution if that point is true for both equations. Basically, that would be the point of intersection. And you can use substitution to double check that. For example, in this one, is 2, 4, the point 2, 4 a solution for the system x minus 2y equals negative 6 and 2x plus y equal to 8. Well, if we plug in the 2 and the 4, into the system, first equation, let's say here, would be 2 minus 2 times 4, and does that equal negative 6? Well, put in the 2 in place of the x and the 4 in place of the y. 2 times 4 is 8. 2 minus 8 is negative 6. So that point is a solution for that line. Then if I plug it into the other one, I've got 2 times 2 plus 4. Does that equal 8? Well, I've got 2 times 2, which is 4, and 4 plus 4 is 8, which is equal to 8. So yes, that one's true for that point. Since that is true for both lines, that means this system is a solution or this point is a solution for the system. That is the intersection point for those two lines. Okay, so let's look at another example. Is 3, 2 a solution for the system 2x plus 3y equals 12 and 8x minus 6y equals 24? Well, if I put 2 times 3 plus 3 times 2, that gives me 6 plus 6, which is 12. So it works for the first line. That point is considered a solution for the first line. You look at the second one, you've got 8 times 3 minus 6 times 2. Does that equal 24? 8 times 3 is 24. 6 times 2 is 12. That tells me that equals 12, which is not equal to 24. So that's not true. And since the point is not a solution for both equations, this one is not considered a solution for the system. Has to be a solution for both equations. Take this moment. If you don't understand this, go back and replay these examples. Rewind and look at it again. Solving linear systems by graphing. You're going to graph the two linear equations. The intersection point is the solution. So basically what we're trying to see is when we graph these, when we see them intersect, that intersection point is considered the solution for the graph or for the system. I am going to show you how to do this by hand. Later on I will try to make a video showing how to do this with the TI Inspire calculator. You will see how that is pretty easy, and if I do make this before you see this before you do the worksheet on Monday, you can do the whole thing with the Inspire. You probably could finish it really quickly that way. Okay, so we want to graph and find the point of intersection for this system right here. Y equals negative x plus 4, y is equal to 1/2 x minus 2. Well, for the first one, I start at positive 4, 1, 2, 3, 4 on the y-axis. Then I'm going to go down 1 over 1. I could continue that. And what I recommend is do several of these points. So you can kind of see where it's going. And then on the other one, I am going to start at negative 2. I'll do that one in a different color. I'm going to start at negative 2. I'm going to go up 1 over 2. Up 1 over 2. And it looks like they're intersecting there at 4, 0. Let me make a straight line to connect my dots. You can see my points were a little bit off, but I get the right idea. And then so this intersection point right here, that point right there, that would be considered my solution. And that point is 1, 2, 3, 4, 0. That is the solution, the answer, the intersection point for this system. Okay, so here's another example. Go ahead and take a minute. Try to solve this problem on your own. See if you can do this. Graph these and let's see what happens. Okay, sorry about that, but apparently I've given you all the same example as the first one. So try this problem, negative 1/2 x plus 5 and 3x minus 9, and see what you get for the answer. Pause the recording at this point and then check your answer when you hit play again. Okay, as you can see here, the answer here should be 4, 3. That would be the point of intersection. You can see how the graph was, starting at 5, going down 1 over 2 for the blue line, and then starting at negative 9 and going up 3 over 1 for the red line. And I did that until the point of intersection. Okay, so that is basically how you do this. This probably would be easier if you have graph paper to work with. It's usually very hard, especially if you're trying to freehand this on regular paper. So if you can, always try to make sure you have some type of graph to work with. Okay, there are 3 types of solutions. Okay, you've already seen one where you say it's one solution. That one solution, we'll talk about that in a second, but that's basically the point of intersection. Infinite solutions, and there's a reason why I drew a yellow line and a white line. It's basically there was 2 lines in the system. They looked different, but they were actually the same line, one on top of the other, which means then you've got multiple points of intersection. You have infinite number of intersections. They would never stop. Okay, both of these right here would be considered consistent systems. Okay, and I ran out of space here, so let me try to do that again. Consistent systems. And what that means is that they at least have a solution. Okay, so you could say you have and we'll talk about the next part in a second. And then when there are no solutions, that means they're parallel lines. They will never intersect. These are called inconsistent systems. Again, this is in your vocabulary, so you should have this, and you're adding this into your Texas Note notebooks to show me. Okay, so when you have an inconsistent system, that's basically the only way you would classify it. But when we look at a consistent system, we can classify them two ways. We can classify it as a consistent independent, which means it has one solution. Independent system. Or we can classify it as a consistent dependent system, which means it's got an infinite number of solutions. This is something that will be probably asked on the quiz or the next test, but it's probably not going to be, it's not going to be on the assignment, so make sure you know how to do that. So tell me how many solutions the system has, and then let's classify it based on that. Well, if we looked at this and we tried to, say, graph it, we would start off at 3. For the first equation, going down 2 over 1. Okay, so you've got a line that looks something like that. The next one, if you solve for y, you end up with y equals 6 divided by negative 3, because I'm dividing everything by negative 3, would give me negative 2x. Negative 3 divided by negative 9 divided by negative 3 would give me positive 3. Well, if you notice here, then that line is basically the same as the other one. It was just written a different way. So this one has infinite solutions. Since it has infinite solutions, we would classify this. So this one has infinite solutions. That means then we would classify this as a consistent, because it has intersection points, consistent dependent system. Now this is something that might be useful to add on to for a note card. Make sure it's in the notes, that type of thing, because that would probably be very hard to remember. Okay, if you look at this example, solve for y. Let's solve that second one for y. Let me do that one in red, and we'll have y here equals negative 3x minus 2. Okay, if you graph that, you would see two parallel lines, one at 3. One at 3, and going up and over, like, or actually down and over 1. So something like this. Whereas the other one would be going, say, starting at negative 2, going down and over 1. So maybe something like that. And again, that means there's no solution, because there's no intersection point. This is these are parallel lines. Now we classify a no solution as an inconsistent system. Misspelled consistent. Inconsistent system. Okay, and again, practice with those. You can follow those in the examples on the book, or in the textbook, or do some of the practice problems in the textbook. Okay, the last thing I want to go over is using a table to find the intersection point. A point of intersection occurs at or when I should have been saying here, a point of intersection occurs at an x. That's what I'm going to say. At an x, when f of x matches f1 of x matches f2 of x. Now I'm using the same terminology that the Inspire uses. You might be thinking y1, y2. But if you look at this, here's an example. F of 1x is equal to 1/2 x plus 3. F2 of x is equal to 4x plus 3. If you graph that, if you type that into your calculator, graphed it, put it in the graphs and geometry section, press Control T, and the table will appear. Now you may have to press sideways to kind of see the graphs, or the F1 and F2 at the same time. But basically at 0 we would see where 3, it would be 0, it would be 0, 3. And we see 3, 3 for F1 and F2 at 0 at the same time. Notice there it's at the same time. So what does that mean? That means that that is the solution. 0, 3 is the solution to that, it's the point of intersection, so that would be the solution for that system. So that's one way we can use a table to our advantage to find that. Okay, so if you go back and look at some of the other examples, like the first couple examples where you had to graph, see if you can actually pull up the table on those and compare to see that solution. See, so you got the intersection point that it was, say for example number 2, 4, 3, and you can see hopefully that on the table. But the idea there is, again, when we press Control T, the table will appear. So on our screen we would see the graph, and then it would be split, and we would see the table, and it would have like X and then F1, and maybe to see F2 you might have to press sideways, so you kind of have to do a little double take. There is a way for us to have it on a separate page. We'll look at that in class, or I'll try to show it to you on the video when I show you how to do intersection points. That is all I have for this. If you do have any questions, feel free to ask Mr. Valverde or the substitute, or send a note through Edmodo. Like I said, I do hope that I may have Wi-Fi that I will be able to answer your questions, but go ahead and do that. Practice with this, do the assignment that you get on Monday, and hopefully everything will be clear so that we can move on Tuesday. Thank you very much, and hope this is very readable. Please do not forget to add in the vocabulary to show me. That'll be for extra credit.